Welcome to our channel. Our first topic is going to be discuss on extraction of drinking water from sea waves. Present system of desalination. Already we know that the present system of desalination is powered by diesel-powered electrical grid to run the plant. Desalination done by passing high-pressure water through the membrane for removal of salt. The pressurizing pumps are the components which needs high amount of power to pressurize the seawater for further process of reverse osmosis. These pumps works on the electrical power given by the diesel-powered electrical generator. The main disadvantage of this system is carbon emission, and the relative cost for desalination increases because of cost of diesel. This is the conventional system of diesel-powered desalination method. Chemical additives are used for pre- and post-treatment process. And also, electricity power is required to run the motor. Nowadays, this system became ineffective and costlier. This is the overview of how salt water can be converted into the drinking water without any electricity, with help of wave. The concept is on wave-driven desalination system. This desalination plant replaces conventional diesel-powered desalination system with a wave-driven desalination process. The initial process includes pre-treatment of the seawater is treated in the shore. Then, the pre-treated water is pressurized by wave energy converter, mentioned as WEC. The pressurized seawater given to the reverse osmosis process for desalination process. At the end of the reverse osmosis, we obtain fresh water, and the fresh water is distributed and stored. So, this is overall setup for extraction of drinking water from waves. Step 1. Seawater pretreatment on shore. Step 2. Seawater pressurized by wave energy converter setup to pressurize the water inlet of RO. Here no any external power is needed. Step 3. Freshwater production by RO. Step 4. Freshwater distribution and storage. Step 5. Brine dilution, and discharge the remaining water. This can be reduce the water scarcity on coastal areas.
The primary objective of pretreatment system in desalination is to make the feed water compatible with the membrane for further processing. The seawater is treated with the chlorination process. It is the process of injection of sodium bisulfite or metabisulfite into seawater for killing microorganisms. The natural organic matter, dust particles and other suspended particles can be removed by coagulation, followed by deep media filtration for low turbid seawater. The antiscalant solution is treated on seawater before the reverse osmosis process to disperse calcium carbonate and sulfates precipitates in order to avoid scaling. The fine filtration, sizes 5 micron, is the last step of pretreatment before the RO membranes to prevent any debris, sand particles or piping material to damage the membranes.
The wave energy converter is nothing but a flap which are placed inside the sea area where the waves are high in nature. The flap has hydraulic piston which acts as the pump, in which it does the function of electrical or diesel pumps in conventional desalination systems. A hydraulic piston is placed in one side of flap, which inlets the pretreated water. Once wave strikes on the flap, it oscillates forward and backwards, and, when flap gets oscillating, the water gets pressurized in cylinder. The pressurized water from hydraulic piston, in turn fed to the reverse osmosis process, in order to obtain the fresh water. The next step is knowable one, which is osmosis process. Osmosis is a naturally occurring phenomena, in which it is defined as weaker saline solution will tend to migrate to a strong saline solution. The osmosis can be explained with the help of the semipermeable membrane, separating the two differently, Concentrated solutions. The semi-permeable membrane is permeable to water molecules, but not permeable to dissolved ions and other contaminants. In order to reach the equilibrium concentration, the water will pass from the pure water compartment to the salt-containing compartment to dilute the salt solution. This is called as osmosis. Next is freshwater production, by reverse osmosis process. To separate pure water from the salt water, it is necessary to apply a force in the column of the salt-containing water, to force the water to flow in the reverse direction, thus making the water molecules to flow through the semi-permeable membranes to the freshwater compartment. This is the basis of the process, called reverse osmosis. When pressure is applied to the concentrate solution, the water molecules are forced to flow through the semi-permeable membrane. The contaminants are left behind, since the semi-permeable membrane is only permeable to water molecules and not permeable to ions and other contaminants. Thus, fresh water obtained at the end of the process.
After obtaining the fresh water from the reverse osmosis process, the fresh water is stored and it is distributed for the people who are in need of it. The brine is nothing but the highly salt concentrated solution, which are obtained from the end of reverse osmosis process. This brine solution is taken from the reverse osmosis process, given back to the sea, by the device brine diffuser. The main function of this brine diffuser is to dissolve concentrated salt water back into the sea. Thus the wastes are reduced, and it does not pollute any water body. By comparing these two methods, wave desalination method is effective and safe to the environment. Diesel-powered desalination needs electricity, fossil fuels and also create the carbon emissions. Away from this, wave desalination also produce secondary electricity.
The advantages includes: number 1, off-grid, can be deployed in remote locations. Number 2, hybrid, produce water and electricity. Number 3, efficient, minimal energy conservation losses. Number 4 and 5, clean and modular. Thanks for watching this video. For more, subscribe now for creative ideas for innovation.